Good morning, students. Welcome to our session. I started lesson 3, acids, bases, and salts. In that, few activities I completed that explanation part. Now, once again, I will recall that all the important points from the lesson 3 and I will continue the lesson. In that lesson 3, just the first one is about the indicators we discussed. Indicators are the substances which we can find out whether the given solution is an acidic or basic or neutral. The next one we discussed about the chemical properties of acids, bases. In that we have so many points. The first one is when an acids react with metals. Once again repeating, when an acids react with the metals, always they liberate hydrogen gas. And even the bases also react with the metals and they too liberate hydrogen gas. But these such type of reactions are not possible with all the metals. Means the bases does not react with all metals. So they cannot produce always hydrogen gas. They cannot liberate hydrogen gas. But coming to the acids, all the acids they react with metals, any metal, and always they liberate hydrogen gas. And the next one is reaction of acids with the carbonates and metal hydrogen carbonates. When acids react with the carbonates, they produce salts, water and carbon dioxide. Even when an acids react with the metal hydrogen carbonate, in that condition also they produce salt, water and carbon dioxide gas. Next one is neutralization reactions. What are neutralization reactions? When an acid combines with the base, then they produce salt and water. Such type of reactions we'll call it as neutralization reactions. Next, reaction of acids with the metal oxides. Reaction of acids with metal reaction of acids with the metal oxides. When they react with the acids with metal oxide, they produce salt and water. They produce salt and water. When we'll get salt, when an acid combines with the base, then we'll get salt. Here an acid react with metal oxides. In this case also, they produce salts. Means here this metal oxide comes under a base, because when acid combines with the base, then only will get a salt. Next, reaction of bases with the non-metal oxides. Reaction of bases with the non-metal oxides. In this case also, they to produce salt and water. In this case, the reaction of base and with the non-metal oxide, they are producing salt and water. Means here base is combined. When will get salt? When an acid combines with a base. So here base react with the non-metal oxide, means here non-metal oxide is having the acidic nature and the metal oxide is having the basic nature. I said in bits it is, these two are very important. Several times they ask in the public examinations also. Next, coming to when metals react with acids, they liberate hydrogen gas. Means what? All the acids, it contains hydrogen element. Does it contain hydrogen element? For that we discussed one activity. What is that? This activity, there are all the compounds containing hydrogen or acids or not. This activity I explained. In this activity, you take one beaker and take acids, different solutions you take. Some are acids, some are bases, and some are now means glucose, water, and different solutions you take, and each time and connect with, these are the graphite rods, and give connection with the AC plug, and this is the bulb, and complete the circuit. And when you switch on, each time you take the different solutions. Suppose if you take the hydrochloric acid solution and you observe that bulb is glowing or not. Next you take the sugar solution and switch on, and you observe the bulb is glowing or not. So in each case when you observe, and in some solution bulb glows and in some solutions bulb is not glowing. Why? Because when bulb glows means when current is passing in this circuit, when current flows, because whatever the solution we are taken, that it should dissociates. Here dissociates means what? For example, if you take HCl, it dissociates into ions. Here means H plus and Cl minus. Whatever the solution we have taken, HCl, it dissociate into the ions. Ions means in last video I explained. When it is losing the electron, it gets the positive charge. When an atom is gaining the electron, it gets negative charge. So when it gets positive charge, we'll call it as cation and we'll call it as anion. So like that it dissociate into positive and negative ions. So these ions, due to these ions, the bulb glows. And if you take the glucose water, that glucose water does not dissociate into ions. So due to that reason, if there is no ions, bulb does not glow because electricity is not flowing in the circuit. Ions are the main cause for the flow of current in this activity. So these are all points we discussed, and one more point we discussed is how to mix water. Means either you mix water to acid or acid to water. That we discussed. We should not mix water to acid. Means if you take a tub and in that if you take acid, and to this acid you should not mix water. Why? The adding of acid to the water, it liberates always heat. Such type of reactions comes are otherwise known as exothermic reactions. Exothermic reactions means always they liberate hydrogen, they liberate heat. So when you add directly water to acid, immediately because of the exothermic reaction, large amount of heat is produced. Maybe due to that heat, the container may breaks and it is dangerous also. So we should not add water to acid. Always you take water in a container. To this water you add acid little quantity, and with the stirrer just you stir it. Like that you mix acid like that you mix acid to water. This process is known as dilution of an acid. We'll call it as dilution of an acid, or otherwise simply we'll call it as diluting. Well, so these points we discussed. Now in this video we have to discuss more about these points. Here you see, in this activity we took different solutions. For example, suppose if you take a strong acid like HCl and a weak acid like acetic acid, otherwise you take one strong acid and one weak acid, and take in the solution and do the experiment and find out whether how does the bulb glows. For example, if you take a strong acid, if you take a strong acid in this and you observe how does the bulb glows. When in case of a strong HCl is a strong acid, you can take sulfuric acid also, H2SO4. So if you take any strong acid, when you observe, the bulb glows brightly. These two are acids. In these two conditions, definitely bulb glows. But we have to observe how does that bulb glows. Brightness you have to observe. When you take the strong acid, if you observe here, the bulb glows brightly. And when you take acetic acid, it is a weak acid. When you take the weak acid in this beaker, and again if you do this activity and if you observe, the bulb does not glows. It glows, but it does not glows brightly. Means like dim it glows. So why there is a difference in these two? Already I said it is a strong acid and it is a weak acid. So by this activity we came to know that it is a strong and it is a weak. Generally, if a solution, if an acids are given, different acids, how you can find out whether it is a strong acid or strong weak acid, or suppose basic solutions are given, whether it is a strong base or weak base, how to find out the given solutions. So generally by using the litmus papers we can find out whether the given solution is acid or base. Just you can find out, but you cannot find out whether it is strong or weak. But we can find out the strength of an acid. Here we can find out the strength of an acid by using another type of indicators we have. That indicators will call it as universal indicator. What is that name? Universal indicator. By using this you can find out this universal indicator is available either in the litmus papers, either not like paper form, or otherwise in the solution form. By using the paper, that paper you can dip into the different solutions and you can find out, or otherwise the solution. First, what is an universal indicator? Universal indicator is nothing but it is the mixing of, the universal indicator is the mixing of several indicators. Several indicators. By using this, you can find out whether the given solution is a strong or weak. By using the litmus papers, you can find out whether the given solution is an acidic or basic. But here, by using the universal indicator, you can find out the strength, the concentration of the given solution. Okay. And to find out, here coming to this activity, strong acid and weak acid. In that, when you are taken in this, when it dissociates into ions, I said, here it contains more number of ions. This HCl, it contains more number of H plus ions. Already we discussed one activity that H plus ions does not exist. Always it exists. H plus ions always it exists in the aqueous solution only. So that's why instead of H plus we should take it as H3O plus ions, or otherwise hydronium ions. We should call it as hydronium ions. In a strong acid, the number of hydronium ions are more, and in acetic acid, the number of hydronium ions are less. So if any solution, if it contains more number of ions, then it comes under a strong acid. And if you take a weak solution, weak acid, it contains less or fewer number of ions. If it is acid, it contains H3O plus ion. If it is a base, it contains OH minus ion. So depends on the number of ions, we can conclude, we can say that it is a stronger base. So to find out, we have to use the universal indicator. We have to use universal indicator. What is universal indicator? It is the indicator mixing of several indicators. And this universal, to find out the cons, we'll call it as if the number of ions are more or less, I said now. So the number of, to find out the number of ions more or less, for that we have to use a scale. That scale we'll call it as pH scale. What is pH scale? What is pH scale? pH scale is nothing but in the given solution to find out the concentration of the ions. Means how many, either the concentration is more or less. To find out this, we have to use a scale. So what is that? That scale is known as pH scale. This pH scale was introduced by Sorensen. Who was introduced? Sorensen. Like the distances and all to measure, we are using a scale. Like that, you can find out the concentration of a given solution by using pH scale. What we'll call pH scale. This scale contains values from 0 to 14. It contains 0 to 14, and in the middle it has the value 7, and it has values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Like this, the scale is having the values from 0 to 14. And each value, it has some different colors. It represents some different colors. Like red to blue. Red to blue. Means first it has a dark red, otherwise the redness here in our textbook, that picture is given. I will show you that picture once. You see, this is the picture. This is known as pH scale. By using this you can find out. It has values from 0 to 14. 0 to 14. And if you observe here, dark red, and gradually the color of the redness is decreased and the color of the blue color is constant. The darkness is increased, or otherwise it given some other colors. So by using the colors you can find out. For example, once again I will explain. If here you see, from 0 to 6 comes under acidic solution or otherwise, and 8 to 14 comes under base, or the solution is basic solution. The number 7 comes under neutral. Neutral is nothing but salts, comes under salts. For example, you have the different solutions. You have given different solutions. Suppose 4 or 5 solutions are given. So we don't know what are the solutions, whether they are acidic, basic or neutral. We don't know whether they are strong or weak. So you want to find out. So you so in that solutions, you take either, I said that universal indicator is available either in the form of paper or in the form of solution. You take any one. Suppose if you have the paper, like so that papers you dip in that and check the color, and that color you have to compare with. So all dip the universal indicator paper in the solution, then the paper turns into the different colors, and that color of the paper, just you compare with these colors. By this you can find out. Suppose a paper in that solution, suppose in this solution the paper turns into like this color, like this color, yellow color, then this value comes under 1, 0, 1, 2, this is 3. Sorry, this is given as, yes, 3 only. This is 3. Means its value is, means the given color, when you compare with this table, you will get the values. Means this comes under 3. Suppose if it comes under 11 and if it comes under 1, the color is suitable to 1. Some solutions color suitable to 8. Like that if you get, and if it gets 7 and if the color is 8, like this, if you got, when you compare the colors with that scale, with that universal that I showed you now, so you got the values like this. From this, here 1 means the given solution is acidic, because from 0 to 6 comes under acid, so it is an acid. 7 comes under neutral means it is a salt. 3, 0 to 6 acid, so this is also an acid. 8, from 8 to 14 comes under bases. 11 also base. So like this, by using the universal indicator, we can find out the given solution is strong or weak. Here I did not mention, I said only whether they are acidic or basic. Now coming to once again this scale, here coming to 1, here 1 means it comes under strong acid. It comes under strong acid. Means in at 1 the number of H3O plus ions are more and OH minus ions are very less or 0 or 0. So here H3O plus ions are more means it comes under strong acid, means its concentration is more. Like that when you go on, if it comes under 5, when you come under 5, here the H3O plus ions are gradually decreasing and OH minus ions are gradually increasing. But when you compare, then OH, H3O plus ions are more. So that's why it comes under acidic nature. Coming to the neutral. Here in this case, the number of H3O plus ions and OH minus ions are same. These two ions are same. When these two are same, the solution becomes neutral. Becomes neutral means it comes under salt. Next, coming to here from 8 to 14. Here when coming to the 8, when or otherwise here when coming to the 8, value of 8, in that H3O plus ions are decreasing and OH minus ions are gradually increasing. In this case, H3O plus ions are very less and OH minus ions are more. Which is more it is having that nature. So here OH minus ions are more means that that value is having the basic nature. And when you go to 8 to 9 and so on till 14, this in at the 14 value, the number of H3O plus ions are completely zero, very less or completely zero, and OH minus ions are more. So when you compare this, which are more? OH minus. When OH minus ions are more, then it comes under strong base. It comes under strong base. From 8 to 10 or 11, it comes under weak base. From 12 to 14, it comes under strong base. Like that, you can compare the values by using the universal indicator, whether the concentration of the ions, by using either the color change or otherwise you can compare with this scale. That color changes you can apply to this scale. So this scale is known as pH scale and this was introduced by Sorensen. It was introduced by Sorensen. Now you take the universal indicator, either the paper or the solution. In our daily life, whatever the acids or bases are available, generally in the labs we have hydrochloric acid, nitric acid, sulfuric acid, acetic acid, and bases sodium hydroxide, calcium hydroxide, like we have the different bases. So collect it, and in our daily life you take the several type of juices. And antacid tablet, it is having the basic nature, whether it contains the strong base or weak base, we don't know. We know just it is a base, but we don't know whether it is a strong or base. And juices like lemon juice, tomato juice, and carrot juice, banana juice, and the saliva, rainwater, and like you collect the different solutions, and using that indicators, universal indicator, you find out. You will get the information whether they contain strong acids or strong base or weak or strong bases. Like that you can find out. Okay, just we discussed about the universal indicator, and to find out we have to use this pH scale. And this pH scale is very important. These pH values, suppose if you find out a soap or paste or any objects, in that they may mention the pH values of that particular substance.